Bem-vindos a mais uma conversa Nós e a Ciência, da Fundação Francisco Manuel dos Santos, uma parceria com a editora Desassossego. Hoje falamos com Sean B. Carroll a propósito do lançamento do seu livro Uma Série de Felizes Coincidências. Este livro leva-nos através de todas as provas sobre o papel do acaso na formação do planeta, no aparecimento de vida e da espécie humana. Sempre que atiramos uma moeda ao ar, sabemos que pode calhar uma de duas coisas, porque será tão difícil aceitar esta aleatoriedade no aparecimento de matéria e de vida. Uma viagem pela sorte e o azar de termos vindo aqui parar, pelos vistos, tudo uma enorme e feliz coincidência. Sean B. Carroll é biólogo do desenvolvimento e evolução, cientista, educador, autor de livros de ciência e de divulgação de ciência e ainda produtor cinematográfico. Lidera o Departamento de Educação para a Ciência do Howard Hughes Medical Institute e dirige o Howard Hughes Medical Institute Tangled Bank Studio, ao mesmo tempo que ensina Biologia na Universidade de Maryland e é professor emérito na Universidade de Wisconsin. Enquanto investigador, tem trabalho internacionalmente reconhecido e premiado em Biologia da Evolução, em particular na evolução da diversidade animal. E como divulgador, tem publicado vários livros e contribuído para a comunicação de ciência através da imprensa escrita, da rádio e televisão, bem como produzido documentários, séries e curtas-metragens. Welcome, Sean B. Carroll. It's a pleasure to have you here with us today. I was fortunate enough to read your book in Portuguese. It's now being released here in Portugal, and where the main idea that you're defending with the book is that chance is what's the main force driving us, also in biology and geology and the planet. And so you in the introduction, you say you're trying to, let's give chance a second chance. So why do we have to keep fighting for giving chance a second chance? Why is it?
Well, thanks very much for having me. Thanks for all the interest. Well, I mean, it may depend from culture to culture, but I think it's probably fairly common among humans that we have an unusual relationship with chance. On the one hand, many of us enjoy games of chance, going to casinos or betting on a sporting match or something like that. But when it comes to our lives, our natural lives and the lives of our loved ones, we would like to reduce the role of chance. We would like to think that maybe either some people might believe there's something more powerful looking out for us, or that we have more control perhaps on our own destiny. But the more we learn about the planet, the more we learn about human biology, the more we understand that chance has played a huge role in the story of life, and played a huge role in just our unique being. And I think it's something that for some audiences will astonish, delight, even inspire, and for others they'll find it a little more unsettling.
Yes. Well, I'm sure it's you do take us through all that you just mentioned. Like in games, we can understand that in a casino, we might be more prone to having a luck, the black or the white, the black or the red coming up on the game. And when we roll the dice, we know it's luck. But when it comes to biology and to our actual lives, it's more surprising, but it's completely there. And also, of course, the fact that we had this massive, you explain it very thoroughly in the book, that we had this massive asteroid that changed completely life on Earth as it was, but not only the geology, but also life on Earth as we knew it.
Exactly. And in such a profound way that without this asteroid, and maybe it's worth going back through some of those details, but many people may have heard that 66 million years ago, a large asteroid hit the Earth, hit the Yucatan Peninsula, now part of Mexico, and triggered a mass extinction. And the evidence for that mass extinction you can find all over the globe because it left behind a boundary, a layer, a fallout layer that below which that previous world was really dominated by dinosaurs. It was the age of reptiles. And above that boundary is really the beginning of the age of mammals, of furry creatures like ourselves. Our mammals existed for a long time before that asteroid, but really were not a major contributor to sort of the doings of the animal world. But once the reptiles were wiped out, mammals really became much quicker, much larger, and much more diverse very quickly, within even the first million years after the asteroid impact, and gave rise to all the major groups that we know about today, including primates, who are, of course, our ancestors. So this asteroid that may have been circulating the solar system for 4 billion years. It just happened to enter the Earth that day. It matters even where it hit on the Earth, because probably if it hit most other places on Earth, it would not have triggered a mass extinction. But had that not happened, you and I would not be having this conversation.
Yeah, exactly.
There would be no Washington, D.C. There would be no Lisbon. We might still be on a dinosaur-dominated planet. And so by that slim margin, life changed forever.
Yeah. Yes, you explain it. It's very thorough and it's very funny. So you take us through a journey that it's quite witty and funny. I enjoyed very much reading your book because it's for someone like me that loves science. It was nice to see it put that way. But if someone doesn't know about the science, you take us through it. You really take us through it, helping us and taking us by the hand. And of course, dinosaurs and the extinction of dinosaurs is something that makes us dream, because sometimes all kids dream of maybe we could live with the dinosaurs, but you explain it very clearly that the only reason we exist is because we don't have dinosaurs anymore.
Yeah, it's so clear that the great dinosaurs sort of kept mammals down, because mammals existed for about 100 million years alongside dinosaurs, but they're all very small and, not that significant. Take away the dinosaurs and mammals became large very, very quickly. And this is well documented now in the fossil record. So it's, very clear that our fate, or at least mammals' fate, was linked to the fate of the dinosaurs. And this asteroid changed the fates of both groups. And and thank you for the kind comments about the book. But the book is trying to be a narrative, a story, the way we might talk about it, at a dinner party or something like that, which is to connect sort of real life events, the close calls that, or even tragedies that some of us might experience or our loved ones might experience, and to understand what a thin line there can be between life and death, between either the world turning this way or that way, or our individual lives being made or not being made.
Mm-hmm. Yeah, I think maybe now we could stop a little bit so you can explain us what you mean by chance, because you do take us also through that, because chance is not just random. It's not like I'm here with you, but I could have a piano falling down on my head right now. Chance isn't, you define very well the difference between the different types of chances we can think of, because there are some things that can be completely random. For example, we know when there's the fertilization, you can either be a man or there's a 50% chance to be a man or a woman, but then there's a pool of chromosomes, but then there's a combination of chromosomes. Can you take us a little bit? What does chance mean to you biologically and when?
Well, let's make it very personal about each one of us. So, because each of our parents had two versions of each of 23 chromosomes, and they inherited those chromosomes from their parents, so you can think about your grandparents and so forth, that in the making of each one of us, or think of any couple that's having a family, how many genetically unique children could they have? Well, there's 23 chromosomes, and there's 2 copies of each, and mom and dad each contribute 1 copy of each of their chromosomes to the egg and sperm, respectively. And the number might surprise everybody. The number is over 70 trillion. That one human couple could have over 70 trillion genetically unique children. So maybe we should all celebrate the fact that we are so unique that there will never be another one like us, ever, on the planet. But at the same time, our uniqueness is this product of this, these chance events of all these chromosomes sorting out, and of which individual lucky sperm makes it all the way up the fallopian tube and fertilizes the egg. So, I think that's sort of the closest personal understanding I can bring of chance to anybody is to realize that you're in your own family. You're a 1 in 70 trillion genetic event.
Yeah, so it should come as no surprise when you have several children and they're all completely different between them. So it's normal, it's expectable.
And something to celebrate. I mean, that process, that random sorting of chromosomes is one source of diversity, but there's another source of diversity that takes place in that same process, which is the introduction of new mutations. Each one of us is carrying maybe 30 or 40 mutations, which means changes in the text of DNA that didn't exist in either one of our parents. Now, that might be worrisome. Most of those mutations are pretty much have no effect. Some do, some affect, how we look, or it might even affect our health. But that process of mutation, which is random, and we understand now much more fully how random it is, that's the source of all diversity on the planet. That if there was not mutation, life couldn't change. So everything from bacteria to butterflies to dinosaurs, to great artists, well, that diversity is based on this mechanism of change. And so again, something I think one can celebrate in one mindset or worry about, perhaps in another mindset.
Yeah. I particularly enjoy the way you talk about Jacques Monod from the beginning of the book, and then you take us again when you talk about DNA, because as you written in your book, Jacques Monod is known by us, that we know about biology. Of course, we know him, but he's not generally known. And I really enjoy the idea of him as a young, beautiful man in Monte Carlo. It's a very, very nice idea. But then when he started to know about biochemistry and genetics, it came to be very clear that mutation is not just random. It's not something that happens all the time, but it's super important, as you were saying. We need to have random changes and mutations. It is mandatory for life.
It's, as I explained in the book, it's an intrinsic property of DNA, of the bases that make up DNA. And people think of mutation as a mistake, an error, a negative thing. Well, really, it's part of the chemistry of DNA, because DNA is not entirely stable. The bases have little changes they go through. And if they're sort of caught in the middle of one of those changes, when DNA is being copied, there will be a mutation. And so what I say in the book is mutation is not what we say is a bug in DNA. It's a feature. That it's inevitable, it's unavoidable that changes will occur in DNA because of the properties of DNA itself. And that's, again, I think, a pretty profound insight from biology, one that we now understand so much better based on work even in just the last 5 or 6 years. So, our command of understanding the mechanism of chance has just grown so much in the last 50 years.
Maybe the word mutation has its bad view because we associate it with cancer, but you've given us an extraordinary example of a protection against an infection by HIV, which is a very, very interesting story. And mutation can also protect us. It's not just originating illnesses or problems or whatever, because I think it's bad. The reputation comes from there. But can you please explain us how good mutations can be? And this example was a very striking example.
Yeah, I think the negative connotation comes, has been around for a long time, that mutation is something that's, threatening, but it's the source of all adaptation. And so one example I give of humans is that there was a discovery in the 1990s of some people that just could not be infected by the AIDS virus. And it turns out the reason is they had mutations that altered the receptor on our cells that the AIDS virus uses to get into our cells. So with that entryway closed due to mutation, these people could be exposed to AIDS their whole lives and not acquire the infection. And there's a fair number of people that have that mutation. But in the animal kingdom, it's so clear that, I give some examples in the book of, the way birds are able to fly over the Himalaya or over the Andes. They have mutations that have changed the way oxygen is carried in their bloodstream. And we know that, things like the woolly mammoth had changes that allowed them to adapt to very cold climates. And, anywhere you look in the living world, creatures have evolved ways to adapt to circumstances through mutation. Now, when mutation happens, it's totally random. It has does not take into consideration the consequences of that mutation, that whether that mutation survives and is propagated and spreads, well, that depends upon other circumstances. But the existence of mutation is constant. New mutations are arriving every time a new individual is born or created. So this is a big idea of biology. It's very hard to understand how complexity and beauty and diversity comes from a random mechanism. But I hope the book explains that in an accessible way.
It does. And maybe we can now go a little back again in history and talk about Darwin. We cannot talk about all this without talking about Darwin. And you tell us in a very compelling way the way he went into the Beagle, how he got into the Beagle, and all the trip, and a series of random things that happened along the way that he was quite determined to continue observing. But how it's also Darwin's trip and discoveries and his observations are also a wonderful account on how we do science, because he had to observe a lot, because what he was finding out was so new and so different from everything everyone thought to that time. So he had to do a lot of observations.
You're absolutely right. And he boarded the Beagle really with conventional ideas that all scientists were holding. And that idea really was that, everything had been created by God in its present form. Darwin had really no reason to sort of suspect that was wrong. But as he traveled, he made these observations that didn't fit with the idea that everything was specially created sort of in its place. And as it was a 5-year voyage, so it was a lot of observations. And when he came back to England and started thinking this through, he realized that in fact, there was variation everywhere in the world. Any group of creatures he looked at were slightly different from one another. And he realized, well, geez, if some of these differences give them an advantage, those differences will be propagated to their young. And eventually the population will be more like them than like the others. And so very logical, but he had to work on this quite a long time. So he came up with the notion, that these variations, which he didn't know how variation happened. We had no science of genetics in Darwin's time, so he didn't know where variation came from. He just knew there was variation among organisms in the world, and he realized that those variations could give performance differences that could eventually lead to changes in whole populations and species. With no science of genetics, and I talk about this in the book, Darwin was so close to understanding chance. He realized there were some observations that put him on the right track, that chance was at work in the making of variation. He observed, for example, that breeders, if they wanted to breed a new strain of plant, or they wanted a new breed of, say, cow, that you wanted to start with large populations. You want to start with a large herd or a large greenhouse full of plants, because they knew that the more you had, the better the chance that a variant would be there that you'd want. And so he said, well, if that's a matter of numbers, then there must be a chance mechanism at work. But it would be 50 years before we had, even better idea of what that might be. So Darwin was close, but biology just wasn't far enough along to tell him just what the pivotal role chance played in making variation, which is the fuel for evolution.
Yes, and since the ideas were he was also very it took him a long time to publish. It was only when Alfred Wallace wrote to him that he finally got the nerve to publish their work Ensemble. They're both published that year, and there's this famous sentence that nothing of relevance was published this year when they published the theory of evolution that year. So this is also a great account on how science is made. Is when you start seeing things completely new for the first time, it makes you insecure as a scientist. And so he waited for a validation for one of his peers that saw the same thing on the other part of the world, because Wallace also traveled to earn his living. And so they were very cautious in publishing because they knew it was going to be very hard. Chance was going to be these variations. They didn't know exactly what it was, but there was a chance element in it. And it was hard to change the narrative for them. They knew it would be hard.
In a world that believed everything was designed by a creator, chance was unwelcome and variation was unwelcome. And so they knew that they were up against that. And Darwin felt he had to amass a lot of evidence. So it took him 22 years, to put together the story as he understood it. And, he was right about his critics. I mean, there were, and I don't mean, these were not nasty critics. These were well-educated people who who had objections, Darwin anticipated, to the theory of evolution. And because basically it said you just didn't need all the design you see in nature, you didn't need a designer. This was the entire shift of perspective that, all these organisms so equipped, seemed to be so well equipped for life that you did not need an external designer, that this process of variation and competition would shape all of the diversity of life. And by taking a designer out, at a time in the 19th century where the church, had such a huge role in society across the globe, this was a very uphill climb. And, in my country, it's still an uphill climb that, less than half of Americans accept an evolutionary explanation of life or of human origins, 160 years later, despite all the evidence. So, still have work to do.
Yeah, yes, undoubtedly, and I'm sure this book will help. One of the things I like, another example I also enjoyed was that Darwin then became more fierce of his theory, and so one day they brought him an orchid that was particularly long, and so he predicted that there had to be a moth with a very long tongue to get to the bottom of it to fertilize it. And then 40 years after this prediction and 20 years after his death, they found the moth in Madagascar. And I got the chills thinking how happy he would have been to have known this for sure.
Fantastic case. Darwin, the reason why you see scientists smile about Darwin, the more you dig into Darwin, the more you're in awe of his creativity. You also learn what just a good, decent human being he was. He was a sweet man. He even served as magistrate of his village. So, he would arbitrate local disputes, because he was so trusted for his reasoning and his empathy. But he was always exploring, more of the natural world to test his ideas. He spent lots of years studying barnacles. And then he decided to study orchids because they were tremendously popular in England and they were fascinating plants. And someone, sent him this Madagascan orchid with this enormous pollen tube. And Darwin said, well, and he experimented. He would put a little rod down and he saw how far he had to stick the rod down for pollen to come up on the rod. And he said, well, for this to work, there must be a moth with an extremely long tongue that goes down this about 12-inch long tube. And as you said, it took decades to discover it, but of course it was there, and it was there exactly where that orchid lived. It wouldn't make sense to find that moth somewhere else in the world. It only works, on the orchid there in Madagascar. So the power of prediction, right? We know that that's part of the scientific process as well. If you can make predictions and those predictions are then borne out, that's yet further evidence that your theory is more robust, is stronger. Every test of the theory can strengthen a theory. And that's all that's gone on really for Darwin's theory for 160 years, is understanding that this is in fact the way the world works.
Yes, and one of the things that maybe you can explain a little bit better is the role of chance in all of it, because chance provokes small mutations in DNA, as you were explaining, and then the ones that are better adapted to nature, or how you eat or how you live and your climate and everything, those are the ones that get selected.
That's right. So there's two parts to this process, and I really try in the book to distinguish these, because I think there's a lot of sort of blurring. We've all heard of natural selection. That's Darwin's baby. That's his brainchild. That's that competitive mechanism. But the question of where the variation comes from in the first place, well, this is chance. This is chance changes in DNA. And we haven't thought about how chance is an inventor. We haven't realized that mutation alone can change the properties of creatures. And that's the invention, the ability to fly at high altitude or live in very cold water. That's endowed by these mutations. Now, as you were saying, when those mutations improve the fitness of creatures to where they're living, those mutations are kept. They're propagated. They can spread through the population over time. If a mutation decreases performance, makes creatures less able to live where they are, they don't spread at all. They disappear very, very quickly. So I want to make a distinction between the chance mutations that are sort of the material of change and the propagation of those changes by natural selection. And biologists have talked for a century and a half about natural selection, but not so much about chance as an inventor, about how chance alone can change the properties of organisms. And then those properties can spread, through a whole population. So the reason I talk about chance having a second chance is it's the less talked about part of evolution, is the chance basis of it. Yet it carries, I think, a bigger philosophical impact because of this, because of humans not really wanting the world to run by, according to chance. This is the deepest evidence of chance, the fundamental role of chance. So I think it is important to talk about sort of in terms of its philosophical implications. And this is in fact what Jacques Monod had to say 50 years ago. Let's talk about chance, because it's going to affect our mindset.
Yes, I think maybe it's because it's hard to understand and difficult to grasp. I remember back when I taught cell biology, every time I talked about chance, they were like, we want answers. We want definite answers, and we are seeing that now. We have so many uncertainties we have to communicate as a scientific community, so that people have a problem with the uncertainty associated with science, and chance is the top of it all, right? We don't control, we don't know.
We don't know that everyone listening to this conversation has mutations that didn't exist in either of their parents. Every person listening to this conversation is a unique genetic combination. And if you think about, all of the creatures on Earth, they are carrying sets of chance mutations that may contribute to their success in a changing world, or they may not evolve the mutations that allow them to keep up with a changing world, and they're going to go extinct. And that incredibly important role of chance is hard for some of us to accept, but it's very much a reality.
Yes, and sometimes when we say we don't know is because we know more about science. So we know the limits and sometimes it's good that we don't know when something happened to take us there. Another very interesting, you also take us through the discovery of DNA, the molecule of life. It was such an important discovery by James Watson and Francis Crick, and it's impossible not to think of the beauty of it. Just 4 building blocks, and then we get only 20 amino acids to build proteins, and with that we get from bacteria to us, to all kinds of life that we see on Earth. It's absolutely amazing. And maybe the simplicity of it, and it's how beautiful. I have a DNA model in my office, and everybody that gets in, they like, it's so beautiful. It is, and also the power of beauty to communicate. And how the importance of the molecule being on the same time complex and simple, it's the secret for its success in biology.
That's right. That's right. And I think, the way you spoke about this, which was, I think, was very impassioned and very emotionally, this is, I think, what science has to offer. It has stories of awe and wonder, of reality, and so that's part of what I hoped with the book, is to appreciate that, these things, if you can make them accessible, these ideas are exciting. They're astonishing. They're enriching of our lives. And so while we may talk about things that how chance makes people uncomfortable, it is awesome. It is awesome that all, from bacteria to blue whales to dinosaurs have come about by this mechanism. It's awesome that we've figured it out in a relatively short period of time. Let's give humans a little credit for their, ingenious discoveries. And I think, again, in that mindset, it's something that it enriches our understanding of the world. And, that's how I hope this book will be received. Understanding, though, that some of it may be challenging to things that some people hold dear, which is, the role of external intervention sort of in life.
Mm. Yes, I was also thinking that throughout I was reading the book, and I was thinking somehow, somewhere you would kill the divine in this book, but you don't do it. You don't go there. And I was thinking about how many times that scientists and science have flirted with the divine, because there are just some things we don't know, and you can believe in chance. I was thinking about, I don't know, Einstein saying God doesn't play dice, and I couldn't stop thinking about that as I was reading. I would argue, with your book, you would say if there's a God, he obviously only plays dice, because it's completely by chance that things happen.
He's letting the dice roll all day long, year in, year out, for millions and billions of years. The dice have been rolling. This is the mechanism, and that's just an interesting discussion. I as an evolutionary biologist, I've had lots of discussions over the last 20 or 25 years with people of faith, people with no faith. There's discussions to be had there, but science deserves a place at the table. Science has new empirical knowledge to share, and I even in the end of the book, I take on some of these more philosophical issues, understanding that there's going to be a diversity of thought about this. There's not going to be diversity of thought in the scientific community, because the way science works, we test these ideas out and we put them through very strenuous testing. But when they come out into society, they come out into a society where there's lots of pre-existing ideas, some of whom will see compatibilities, some people will see incompatibilities, and we have to wrestle through this. And what I just don't want to do is present this in a way that people will dismiss it, out of hand. Oh, that scientist has some motive, some sinister motive, and I won't listen. I want people to entertain, what this means, because if you look, for example, chapter 7 in the book deals with cancer. I mean, this is something that most of us are going to deal with individually, and we're going to deal with our loved ones. And our understanding of cancer has just transformed in the last 30 years. And our treatment, and therefore a diagnosis and treatment of cancer, has been transformed through that knowledge. But we understand there's a enormous role of chance in the making of cancer. And therefore, when bad things happen to ourselves or to the people we love, these are the most challenging moments in our lives. And I hope by understanding the role of chance, it helps people work through it a bit. I give the example of, if someone has a child struck with cancer, to help them understand there's nothing they did to cause it. There was nothing they could have done to prevent it. This is just the bad luck of what goes on in DNA. I don't know, that might give people at least some help, because I think, for parents, this is their worst. We often would say this is their worst nightmare. As all of us get older, our chance of cancer at age 70 is 100 times higher than our chance of cancer at 35. And now we know why. because every time our DNA is copied, it picks up more mutations. And the older our cells are, the more likely they've picked up a mutation that might make those cells behave in a cancerous way. So this is why the understanding of chance is so important. This is real life, and then that knowledge is actionable in other ways. So I'm hoping that that's some balance of perspective for folks to understand that chance is not merely a philosophical entertainment, but it's very much a part of being alive on this earth and of everyone's everyday life.
Yes. Cancer is something that strikes us or struck us somewhere along the line, and it's completely by chance that we get it. Of course, there are some things we can do to make our chance a little better, and with most of it, it's chance. If you play the lottery more times, you will be more likely to win. If you play the lottery less times, you'll be less likely. So the mechanism for cancer is more or less the same thing.
That's right. And we now very much have a clear idea that, people with very little melanin, like me, have to be very careful in the sun, because the ultraviolet rays of the sun damage our DNA, and that contributes to the making of cancer, particularly skin cancer. So, there are things I can do to reduce my chances. And that's the same, for example, with cigarette smoking and things like that. But in many ways, it is just a byproduct of being alive and of our DNA-based life. That the older we get, the more mutations that accumulate in our cells. So these are not mutations we pass to our kids. It means that, in a little patch of skin or, in a few cells in your liver, there may be some mutations that have the potential to, create disease. And the chance of that goes up the older we get.
In your book, I will not say very much about this because it's a little treat you have for people by the end of your book, that you have this little conversation with a series of all kinds of different people, from Camus to Ricky Gervais and Eric Idle and Eddie Izzard and Seth MacFarlane. You talk also about the coincidence of him. I think about this so many times. He lost one of the planes that went into the Twin Towers and 9/11. So many times, and narratives and movies explore this narrative and what happened if this or if that, and it's a very useful narrative thing to use. But in the end, you talk about all of them because, as you say, most comedians also flirt with the theme chance, and it's very interesting. But one of the things that's also very interesting is some of them, especially, at least Ricky Gervais, he's very known for being a science advocate. And every time I see him talk about science and the importance of science endeavors and the difference between science and other things that could help us understand the world, he's always very compelling and very enthusiastic. And I also know that you make movies as well, and you make documentaries, and you're doing one. I will go into that in a couple of minutes, but. How do you feel about this, having these public figures that are so well known? We have Jacques Monod on one hand that only the biologists know, and then Ricky Gervais that everybody knows about him. So it's important to have advocates for science, to have our ideas out there to help us give chance a second chance, or whatever other science themes we are working on.
Well, I bring them up. I love comedy on its own. For its own value. I love comedy and I love these comedians. But I started to realize that they often spoke about things that mattered to me. And I thought, wow, I thought they were just telling jokes. But you look at a lot of their content and they're addressing some meaningful matters. And not just, their comments of pro-science are, greatly appreciated. But I wondered why they went into some of the subject matters they went into, and often, for example, dealing with religion, which is certainly in my country pretty tricky in many places. And I don't want to give away too much of that conversation at the end of the book. Thank you for describing it as a treat. I placed it there as what I hope people would see as a treat. But I reached out to some of these people and they kindly answered. Some I got quotes from other interviews that they had given. But what struck me, what they were all saying was they saw themselves as truth tellers. The comedians saw themselves as truth tellers. And that was so powerful to me because, of course, this is what we perceive ourselves as scientists, that we have this system of knowledge, of producing knowledge that we hope gets us closer to the truth. And this is what scientists and comedians have in common, is that search and that valuing of the truth. And, you know, my country has lived through a period of the last few years where truth was very scarce and shockingly so, you know, in the public sphere. And so, you know, I think to reassert and cherish the values of truth and truth telling is so important. And to have allies in entertainers and comedians is very, very important and very much appreciated.
I would like to talk a little bit in our final minutes, talk a little bit about your filmmaking process. You have been covering vaccines and climate change and very difficult issues in science to deal with, and very difficult to deal with governments and to deal with people and to help people understand how can they contribute to something. I would like to know, how do you feel how films have been helping you convey the message, and because they're difficult to do and difficult to get out in the open. How do you feel about and you're also directing this this film production at the Howard Hughes Medical Institution. So it's very interesting to see that happening in a scientific institution, that you have a producing part to make the movies. Can you tell us a little bit about that?
Yeah, thank you for asking. And it is unusual from a scientist's career point of view that you wind up, whilst I still have a lab, I'm still doing science, but I've taken the storytelling that we do in books, you know, and the storytelling in books is a very individual endeavor. I mean, yes, I have an editor and things like this, but this is really me, you know, sitting at a desk or sitting on my back porch and writing and thinking. It's a very individual enterprise. But filmmaking is a very collaborative effort, and I'm not you don't want to see a film that I would make alone. It'd be terrible. So we work with some great filmmakers from across the world to try to bring science and stories about science and scientists to life. And the power of film is manyfold. First, it's a very immersive experience, different than just words alone, right? Because it's images and music and things. Characters play a big role in film, in case, for example, scientist characters, and that gets our emotions going. We may empathize with a character. We may root for this character to find what she's looking for. And film travels very well around the world. So most of our films, they'll be seen in at least 100 countries or more. So it's a much larger audience than, say, for a book. So I like to think of books as sort of this, you know, very disciplined telling of, you know, science around a particular topic, but film then takes some piece of that and, you know, and puts it onto a big screen that people can enjoy across the world. And the storytelling is very different. But being aware that audience for film is very large compared to, say, the audience for books. That's one reason to tell stories on film. The other is, you know, we live in a video world, right? You're doing this interview on video, right? There's people like to see what they're hearing. But we thought, you know, the unusual part of having a production company in a science organization like Howard Hughes was that, you know, we sit in a privileged place in the scientific community. We hear about things that are happening before they may reach, you know, the press or the public attention. We've made films about discoveries that, you know, where we learned about a discovery in progress, and we spent 3 years, you know, documenting the discovery. So we have the advantage of being embedded in the scientific community. And I think that gives us an insight into scientific process, gives us an insight into what makes scientists tick, their passions, motivations. things like that. And by collaborating with great artists, great filmmakers, cinematographers, producers across the world, hopefully we make things that bring those two perspectives together in a strong way. And we hope to make beautiful, inspiring, informative films. And I think sometimes we've succeeded.
I'm sure you have. I'm going to quote you back at you in the interview you've given recently about your next documentary about COVID-19. You're doing a documentary now on COVID-19, on the people that discovered the vaccine and all the process. And there's this quote I really enjoyed that you were saying. You said that people need inspiration that is grounded in real things that are happening. The constant drumbeat of denialism can just lead to despair, but that's not necessarily our future. Our future is still in our hands. That's what you said about
well, I think this is the important thing is I think science has a lot to contribute to our culture, has a lot to contribute to the way forward, and that the challenges we face, in this case, a global pandemic, in other cases, the state of our ecosystems around the world, science has a lot to offer, and it's vital, really, to the health of society. And so, there's a lot. It's pretty easy to fall into a narrative of doom and despair that we're destined for a degraded world or destined for more difficulty. But I think that can be self-fulfilling if you just repeat that again and again and again. I think there are ways out of things. I think there are constructive things that we can do. We can beat this virus. We can restore ecosystems. We can protect species. We can help refill the oceans. We can make food more plentiful and more secure, for human populations. So, science is fundamentally optimistic. Science is hard to do. You have to be an optimist to undertake it. But it's a fundamentally optimistic viewpoint that science can help the world be a better place. And in film and that kind of storytelling, I think that's the voice we often want to use, is not to deny the problems, but to, in fact, talk about solutions. And so I'm much more interested in talking about solutions than dwelling and despairing over problems.
Thank you. Thank you. Thank you so much for being with us today. It was a pleasure to have this talk with you. Thank you so much, Sean B. Carroll. See you next time.
Thank you. Appreciate it.
A todos, muito obrigada por nos terem seguido. Foi um prazer ter esta conversa. Sean B. Carroll, uma série de felizes coincidências. Obrigada.